We're going to continue on with our geometry unit, and we're going to do a little bit less with triangles. We're going to stick with angles and stuff like that, but a little less with triangles and theorems like that. We're going to be talking about angle relationships with parallel sides. So the I can statement for 7.3 is, I can identify and use angle relationships with parallel lines. Now, I'm going to warn you right now, there is a whole bunch of vocabulary here. This is going to seem a little bit overwhelming to start. We are going to do several days on this. It's not very hard. It does take some practice. If you pay attention to the details, you'll be just fine. And again, this is actually kind of one of the cool things about geometry, because we're going to have what look like really complicated diagrams. I'm going to give you a tiny bit of information about it, and then you're going to be able to fill everything in and answer every single question that we've got. So it's really kind of a cool application. So as a warm-up, let's take a look here at these words. So what do the following words mean? Consecutive and transcontinental. Consecutive and transcontinental. Okay, so consecutive, if you've got things that are consecutive, then they happen in a row. So in a row. If you made 14 consecutive free throws, then you'd made 14 in a row. And you may have heard of this before, transcontinental or transoceanic or something like that. Trans means across. So transcontinental means across the continent. Across the continent. Across the continent. If you took a transcontinental flight, you might fly from like New York to LA or something like that. That would be transcontinental. Okay, what symbol do you use for an angle? Well, we use that little angle symbol like this. What symbols do we use to show the measure of an angle? Well, to show the measure of an angle, we're going to write that little m. We're going to have the angle and then the name of the angle, and then it might have a degree sign on it if we're measuring things in degrees. So those are a couple of things that we'd use in order to indicate the measure of an angle. Okay, we need to know and understand the vocabulary. Let's write vocabulary in here. That is not going to go away. Whole bunch of vocabulary today for working with angles with parallel lines. So we've got some parallel lines here, and we're going to fill in the blanks and give examples of each one of the vocabulary for the diagram below. So I've got this diagram right here, and that diagram has a line that's in red. That's line T. And then we've got this line right here. It's line M, and this is line N. And then each one of these angles is numbered. So it looks like we've got 8 angles all together here. So let's make sure we're clear on how this works. I'm going to slide this down so we can see everything here. And let me get that all set. Okay, that looks pretty good. We can see everything on here. So it says parallel lines. Parallel lines are lines that never cross, or we're going to say intersect. Never intersect. Okay, and I'm going to just put cross in parentheses here. Whoops, make that look a little better. Cross. They never cross. Okay, the notation that we use is we use 2 lines that are right next to each other. It kind of looks like 2 L's. And on a diagram, we use arrows. We might do something like this. Okay, so we'll put a little arrow here. Sometimes we'll just use a symbol like that. So as an example, M and N on this particular diagram, they're parallel. So here's what we're going to do to show that they're parallel. I'm going to put a little line right here, or a little arrow right here, and a little arrow right here. And I'm going to go ahead and fill that one in and fill this one in. A lot of times, because it takes a little more time to fill them in, we just use a symbol like that. But either one would be okay. And if they pointed the other direction, that would be just fine. So on this example right here, to indicate that they're parallel, we'll see something like this. I mean, somebody might say line M is parallel to N. And this is a script M. I'm not very good at writing that, and this is a script N. But the fact that we've got this parallel symbol in between those tells us that it's parallel. And then we've got these little marks on here. And I'm actually just going to go through here and make these look a little bit better, and I'm going to put them like that. Okay, so those 2 are parallel. A transversal. A transversal is a line that cuts across, there's the word trans, across other lines. Now, the one that cuts across here is line T. So we're going to say line T is a transversal. Transversal. Okay? Now, Vertical angles, we've talked about this before. Vertical angles are opposite angles formed by two intersecting lines. Two intersecting lines, okay? So examples here would be, gosh, there's a whole bunch of them. Any that are straight across from each other in an intersection. So I'm going to write down these examples. So angle 1 and angle 3. Angle 2 and angle 4, that takes care of those guys. Down here, angle 5 and angle 7, whoops, and angle 7. And the last group would be this pairing right here, the ones that are across from each other, so this would be angle 6 and angle 8. All of those are pairs of vertical angles, and they're of course congruent. We know that from before. Okay, interior angles, angles on the inside. Okay, remember interior means inside. So inside of the two lines cut by the transversal. So we're looking for angles that are on the inside of the two lines. So these are the angles that are on the inside. So I'm going to write interior, interior, and this is the exterior out here, and this is another exterior out here. So the interior is inside here and the exterior is outside. So let's write down some examples of the interior angles. The interior angles would be any of these right here. So we've got 3, 4, 5, and 6. So I'm going to write down angle 3, angle 4, angle 5, and angle 6. All of those are interior angles. So the exterior angles, of course, would be the angles on the outside of the two lines cut by the transversal, in this case those two parallel lines. So the ones that are exterior are 1 and 2, those are on the outside of the two parallel lines, and 7 and 8. So angle 1, angle 2, angle 7, and angle 8. Okay, let's see, consecutive angles. Consecutive angles are angles that are right blank to each other, angles that are right next to each other. So when we say next to each other, that means they're right in a row. Okay, so right in a row. All right, so let's take a look at some that are consecutive angles. These two would be consecutive angles because they're right next to each other. These two would be right next to each other. Those two would be right next to each other. 3 and 4. 3 and 6, those are right next to each other, okay? 4 and 5 are next to each other, 5 and 6. There's a whole ton of them, okay? You can pair up any that are next to each other. So I'm just going to write this, any that are next to each other, okay? So that includes 3 and 6. So as an example, angle 3 and angle 6 would be just fine. Angle 7 and angle 8. What about angle 5 and angle 7? Are those next to each other? They kind of have to share a side right here, or they have to be right in a row, okay? These are right next to each other. These are across a line from each other, so that's why they're not consecutive. And then we've got alternate angles. When we say alternate angles, they're angles on the opposite side and opposite intersection of a transversal. Opposite side and opposite intersection of a transversal. So if this is a transversal, if they're going to be on the opposite side, like 1 is over on this side, it's on the left side. So one of the alternate angles would have to be over here. And there are a couple specific categories. And when we talk about consecutive, sometimes we'll get more specific with those, but I think this idea that we went over is enough there. So let's talk about alternate interior. Alternate interior angles. So interior angles would be ones that are on the inside of the two parallel lines. They have to be on opposite sides of the transversal and opposite intersection. So angles on the opposite side and opposite intersection of the transversal. So let's do angle 4, and the one that would be on an opposite side and opposite intersection would be this one right here. So angle 4 and angle 6, those are going to be alternate interior. And angle 3 and angle 5. So I'm going to put a comma right here. Angle 3 and angle 5. Okay, those are alternate interior angles. So alternate exterior would need to be these guys up here and these guys down here. So let's take angle 1. Angle 1, and I want one that's on the opposite side of the transversal on the opposite intersection. So 1 and 7 are called alternate exterior angles. So angle 1 and angle 7, big comma right there. So you might have guessed that angle 2, if it's going to be alternate exterior with anything, it's going to be alternate exterior with 8. So 2 and 8. So this would be angle 2 and angle 8. Okay, now corresponding angles are this: angles that are in the same place in the other intersection of a transversal. So what we mean by that is, imagine that these parallel lines are streets, and then we kind of come across this transversal like this. Well, if we were driving on this transversal, let's say we're going in this direction, then we stopped right here. 8 would be on our left side, and 7 would be on our right side. Well, if we came up to this next intersection, 4 would be on our our left side, and 3 would be on our right side. I think I said that backwards on this one. 8 on our left and 7 on our right, 4 on our left and 3 on our right. That means 4 and 8, they correspond because they're in exactly the same place on the intersection. 3 and 7 correspond because they're in exactly the same place on the intersection. And then I'm going to change colors here. If we were sitting at this intersection, if we look across kitty corner at the 5, so over there the 5, and then we've come up to this next intersection, I'd be looking at the 1. Those are in the same place. And then the last one I'm going to do is, let's put a big long, well, let's put something like this, okay? Something weird looking like that. Okay, so the ones that have the same shape around them, those are corresponding. They're in exactly the same place in the intersection. So if I came up here, if I'm looking this way and counting counterclockwise, 8, 7, 6, and 5, if I drive up to this intersection and stop, then it would be 4, 3, 2, and 1. So that's kind of how we figure out which ones are corresponding. So let me write down the corresponding pairs of angles. So the one that corresponds with angle 1 would be angle 5 because it's in the same place on the intersection, big comma. With angle 2 would be in the same place as angle 6. So this is angle 6. Angle 3, think about where angle 3 would be corresponding with. It would be corresponding, it's in the same place in the intersection as angle 7. And then angle 4, of course, has to be with angle 8. And angle 8. Okay? Now, the last thing that we want to talk about is same side angles. Same side angles says angles that are on the same side of the transversal. Oh my gosh, it almost says it right there. Okay, alternate angles, that was a little more difficult, but same side of the transversal, so they have to be on the same side. So all 4 of these are on the same side, and all 4 of these are the same size, or on the same side. But we want to categorize these. So same side interior, same side interior. So they've got to be on the interior. Same side interior would be angle 4 and angle 5, comma, angle 3 and angle 6. Okay, 3 and 6 are same side interior, 4 and 5 are same side interior, and then same side exterior. So same side of the transversal but on the outside, so that would be angle 1 and angle 8. Put a big comma, and then angle 2 and angle 7. Okay, now that's a little bit on the small side. I'm hoping that you've got all of that. I can kind of slide this down and you can still kind of see what's going on there on the diagram. But this is all the information. Seems like a ton to keep track of, and that's why we're going to spend several days talking about these. For some of the assignments, all you need to do is identify the pairs that are indicated, and then we're going to use some more complicated ideas to figure out what's going on. So the next question is, how do the angles in the intersections of lines T and M compare with the angles on the intersection of line T and N if lines M and N are parallel? Okay, so what it's asking is, what can we say about these angles that we just talked about. We've got all these funky names for them if those two lines are parallel. So we're going to come over here and we're going to take a look at example 1 and we're going to figure that out. So it says, given that line M and N are parallel, so line M is parallel to line N, how would we indicate this on the graph? So I'm just going to put a little arrow right here, okay? And it says the measure of angle 2 is 50 degrees, okay? What does this mean for the measures of all the other angles on the diagram? So I'm going to write this down as 50 degrees right here. So that is 50 degrees. And then I'm going to ignore this bottom part of the diagram. Going to completely ignore this because we have actually seen something like this before. If this is 50 degrees and this is a straight line, we've got 180 degrees on the top half of that straight line. So 180 minus 50, we end up with 130. So this has got to be 130 over here. So got to be 130 degrees over here. Same thing is true over here. So we have another 180 minus 50. So this is 130 degrees over here. And you've probably guessed, because we've talked about vertical angles before, and I think we actually used these numbers. If this one's 50, that one's 50. If this one's 130, that one's 130. So these are vertical, those are vertical. You'll notice if we add these up, we get 180. Add those up, we get 180. In fact, if we add them all up, we get 360 degrees for going all the way around full circle. Now, what do these have to do with each other? If I take this diagram, this intersection of streets, if you want to think about it that way, and slide it down on top of this, it should look exactly the same. So I'm going to do something on my paper that you can't do on yours because of the tools that I have. I am going to snap a little shot of this intersection right here, copy it to the clipboard, and then I'm going to paste it on here, and we're going to see how this looks. I'm going to slide it around until it's right on top of where it should be. A little bit right there. You can kind of get the idea. Pretty darn close. This intersection looks exactly like that intersection. Okay, so what that means is, I'm gonna remove this in just a second. What that means is that the angle measurements on this intersection are exactly the same as the angle measurements on this section. Okay, so I'm going to go ahead and erase that. And since we know those two intersections are the same, I'm just going to go ahead and write down all the angle measurements. So this angle would be 50 because it's in the same place in the intersection as that one. This one is 130 degrees, this one is 50 degrees, and this one is 130 degrees. Okay, so think back to what we had here. The only thing that we knew was that these two lines were parallel. That's what they gave us in part A, and we indicated that on the diagram. And they told us that the measure of angle 2 was 50 degrees. That was 50 degrees. That was it. So of the 8 angles on here, they only gave us 1, and we found out 7 new angles based on that one piece of information. Pretty cool that we can get that much information from that small amount to begin with. So understanding the example above allows us to make some very powerful conclusions. So if we take a look at this, my gosh, there's a whole bunch of them that are exactly the same. And again, one of the most important things about geometry is developing the ability to take things you already know are true and find new conclusions that are also true statements. Okay, so we're going to talk about some of those true statements, some of those true conclusions that we can make from this. So it says the following pairs of angles are congruent. Okay, so the first thing that we could say are congruent are these type of angles. Take a look at this 50 and this 50. Those are vertical angles. Okay, so vertical angles, those are congruent. All right, so 2 and 4 are congruent. 6 and 8 are congruent. 5 and 7, 1 and 3. Those are congruent. Okay, the next one is, I want you to take a look at this 50, and not the 50 across from it, but the 50 down here. Do you remember the name if they're in exactly the same place in the intersection? So that 50 is the same as that 50. This 50 is the same as that 50. The name there was corresponding. Corresponding was the short way to say they're in the same place in the intersection. Okay, the next thing we want to look at is this. On the inside, this is 50 and this is 50. Now notice it's across the transversal on the inside, so these are alternate interior. alternate interior angles. So these are across from each other on opposite intersections. Same thing with these. So 3 and 5 are alternate interior, 4 and 6 are alternate interior, and they're congruent. 4 and 6 are congruent, 3 and 5 are congruent. The 50 with the 50 and the 130 with the 130. And take a look on the outside. So if we're looking at the exterior ones, that one's 50. That one's also 50. These are alternate exterior. They're on the outside and they're on the opposite side of the transversal. So alternate exterior angles are also congruent. So 130 here for angle 1 and 130 here for angle 7. All right. Now there are some other things that we can say besides just that there are some congruent angles, and it comes from that whole straight line and 180 thing. Okay, so it says the following pairs of angles are supplementary. Remember, supplementary means that there are two angles that add up to 180 degrees. So consecutive angles, consecutive angles are congruent. So take a look at this. If they're right next to each other, 130 and 50, 130 and 50, 130 and 50, 130 and 50. Now the same thing would be true down here, but take a look at this. 3 and 6 are next to each other, that's 130 and 50. 4 and 5 are next to each other, so that's 130 and 50. Okay, so as long as they're consecutive, as long as they're next to each other, then they would be congruent. Okay. We also have same side interior. Okay, if they're on the same side of the interior, that's a more fancy way of saying consecutive. So interior, okay, and same side exterior. So if we did the 50 and the 130 and the 130 and the 50, so same side interior and same side exterior, they are all supplementary. So that means they add up to 180 degrees. So we're going to take a look at a couple of quick problems. And then we might do a couple from your assignment that are even easier. So I want you to take a look at these right here. It says write an equation to solve for each of the variables in the diagram. State the name of the angle relationship you use to write each equation. So we'll assume that these two are parallel. I think that should be the case on every single one of these. So I'm going to go ahead and indicate that on the lines. All right. These two are on the interior and they're on the same side. If they were on opposite sides, then they would be alternate interior. So these are same side interior. Okay, and again, you do have to use the vocabulary, but if you do enough of this, you get really used to it, and it just kind of flows. They're on the same side of the transversal, and they're on the inside, so they're called same side interior. Now let's remember what they were. If they're same side interior, did that mean they were congruent? Does that mean they're equal to each other? Okay, or does that mean we add them together and set them equal to 180? Well, same side interior is on this list right here, so they're supplementary. So 128 plus 2x equals 180. So we're going to subtract 128. 2x equals, let's see, 180 minus 28, that's going to be 52. So we're going to divide by 2, and we're going to get x equals 26. Okay. Now, if I throw that in there and I double it, that would be 52, and 52 plus 128 does equal 180, so we'd be good there. Let's take a look at these two guys here. First thing you want to notice is they are on the outside of the transversal. Here's the outside, here's the outside, so we're on the exterior, right here's the inside, and they're on opposite sides of the transversal. So these are alternate exterior angles. So alternate exterior angles. That was not on the list where they were equaling 180. That was on the list where they were congruent. So we're going to say 70 equals x plus 16. We're going to subtract the 16. So we get x is equal to, and 70 minus 16 would be 54. Put the degree sign on there and we're all set to go. Oh, that was just an x, so we don't need the degree sign on there. All right, and then the last one. This one's kind of interesting. We've got a couple of missing pieces here. Take a good look. These two, the y and the 112, they're on the inside, but they're on opposite sides and opposite intersections. So I'm going to write y equals 112 because those are alternate interior angles. Okay, so y is equal to 112. Circle that so we can see it. All right. And if this is 112, then there are two ways that we can figure this one out. Those two are vertical, so I could say 4x equals 112 because they're vertical. I could also say this, 4x would equal 112 because those are corresponding. So either vertical or corresponding. So I'm going to put vert or corresponding. Okay, and then we just divide both sides by 4 and we get x equals, let's see, if that were 100, that would go in 25 times. It's another 12, so that 4 goes into 12 3 times, so that would be 28. Okay, all right, so there's the answer there. I do want to take a quick look at a few from your assignment, because if you can understand these, your assignment, especially the first one, is going to be a breeze. So I've pulled up 7.3a, the first assignment that we're going to do from this section. And I'm hoping you notice how much easier this diagram is. We've got the little marks here indicating that those two are parallel lines. And then we're taking a look here, and it just says find the missing angle. It does say that you have to name whether it's corresponding, alternate interior, alternate exterior. So it gives you the names that you need to have here. So notice that these are not on the inside, they're on the outside, so they're definitely going to be exterior. And they are on opposite sides of the transversal. So these are alternate exterior. Okay, so I'm going to circle that. And what do we know about alternate exterior? Well, if you wanted to check that on your list, these are congruent. So that angle right there has to be 75 degrees. That's it. Name it, write down what the angle would have to equal, and you're all set to go. If we take a look at number 2, these are on the inside. They're on opposite sides of the transversal and on opposite intersections. So this would be alternate interior. Okay, and I'll just abbreviate that. And alternate interior are congruent. So this one is 54 degrees. It literally goes that fast. We're going to do one more and then I'll turn you loose. Take a look at these guys right here. They are on the same side of the transversal and they're on the inside. So these are same side interior. Same side interior. So what do we know about those? We know that those have to be supplementary. So x plus 84 has to equal 180. If you wanted to just do a quick subtraction problem and get x equals 96, totally okay. I'm going to put 96 degrees right there and circle that, and we're all set to go. All right, good luck on the assignment. We are going to be doing this for several days, so don't get overwhelmed. You've got some time to get it figured out. I know that's a lot of information at once, but it's really hard to cover this in chunks. We're going to start off with relatively easy problems like this and then build up. Ask questions if you've got them, and good luck.